In this video, I'm going to show you how to configure OSPF cost metric. So the cost metric method is an alternate method to reference bandwidth for affecting OSPF path selection. The main difference between the two is that OSPF cost metric is applied per interface. These routers are all in area 0. I've got R1, R2, and R3 that could be a WAN core, and R2 is connected to R4, and finally to DC1. The server's on 172.16.1 subnet. Based on the default reference bandwidth of 100 megabits per second, all these gigabit links are cost 1. So from R1 to the server, there's actually 1 hop, 2 hop, 3 hops, and 4 hops. So the cost would be 4. And that's the path that R1 would take to get to the server, since it's got the least number of hops, and each one is assigned 1. So we'll go to R1 and show you that. So right at the top, there's the route to the server, 172.16.10/24. And there's the cost of 4. It's via 192.168.1.2, gig 001. So the exit interface is gig 001. And the next hop address is R2 gig 000. And there it is there, 192.168.1.2. Run a trace route. And packet tracing, you have to run it twice. So there it is there. First hop, 192.168.1.2, then 4252, then the server subnet. So there's 1, 2 there in R2. That's gig 000. Then 000 in R4. That's 4.2. You can see the top there. Then on DC1, gig 000. See the top there, that's the 5.2. Then the server. So that's the path forwarding. So if there was some reason why you wanted the traffic to forward by R3 and then R2, you could do that by increasing the OSPF cost on gig 001 to make this a higher path cost. So the packets would then exit gig 000. So I'll do that now. So gig 001. The command's IP OSPF cost 10. So I'm going to go from cost 1 to cost 10. That's gig 001 interface on R1. And that's all there is to it. Now we'll do show IP route again. And this time at the top, the route to the server, 172.16.1/24, now has a cost of 5, and it's 192.168.2.2. It's an extra hop, so that's where you get the 5 from instead of the 4, and it's via 192.168.2.2, gig 000 exit interface. And there's gig 000, that's the exit interface. That's from R1 to R3. R3 gig 000 is 192.168.2.2. So now it's changed the path. There it is there, 192.168.2.2, then 3.2, 4.2. Now at this point, if I do a shot on gig 000, that'll install the higher cost route into the routing table of R1. So I'll do that. This is gig 000. I'll do a shot on that. Okay, so I've now shut this interface from R1 to R3, gig 000. Now I'll go back and look at the routing table. 172.16.10/24. Now it's got a metric of 13. That's the cost. Via 192.168.1.2, exit interface gig 001. So it's exiting gig 001 now. It's going over to R2, gig 000. That's 192.168.1.2. The cost on this interface, gig 001, is now 10. So that's the 10. Then R2 gig 002, that's a 1. Then R4 gig 001, that's a 1. And finally DC1 gig 001, that's a 1 as well. That's where you're getting the 13 from. to some of those egress interfaces. I'll look at the cost of that interface there. See, the cost is 10 there. So that verifies how IP OSPF cost works, and that concludes the video.